Hello, welcome to Feliz Math Tutor. Today I'm going to talk about functions, showing them in diagrams, vertical line test, and domain and range. So let's start. What is functions? Function means a relationship between two variables like x and y. One variable depends on the another variable. Let's say we have two sets, set x and set y. So x set we call it input, and set y we call it output, and later we will see actually their domain and range, but now we are using them for x and y. So in set x we have names of people, let's say Alice, Jack, and Mike. In the set y we have their ages, so different ages like 12, 13, 14, 15, and 16. So when we make them uh, ordered pairs, like in the first example, let's say we in the first example f, here we are here now. So ordered pairs like Alice is 13 years old here, Jack is 12 years old, and Mike is 15 years old. So this is a function because every x value has one y value, not more, because we know uh, names only can take one age. So if everybody from set X gets only one age from set Y, then the set of order pairs called function. So the first example is a function. So second example of, let's say, G example, these are also function name, F, G, and H. These are function names. So in this example, we see Alice is taking two different ages. So in real life, it's not possible, right? So we say this is not a function because same x cannot get two different y values. This is not a function. Okay, the first one is a function, but second one is not a function. How about age? Let's choose another color here. Okay, so this age is a function because all the persons like Alice, Jake, and Mike, all of them having same age, which can be possible in real life, right? So everybody can be in the same age. So this is a function with same values, we say. Okay. So let's show these ordered pairs on a diagram. So I will use same example in a diagram. So as we can see, the first one is a function because every person is going to the different y value. So this is function. But in the second example, we can see like Alice goes to the 13 and 15, which is not possible in real life. So we say this is not a function. Not a function. And third example, age example, all of them goes to the 13, same value. This is function. It can happen. So everybody can go to same y values. There's no problem with that. Okay. So function notation for the functions, we can notate it f or f of x. So this one we are reading f of x, or f. So also we can use g, h, I don't know, t, whatever, etc. We can use other letters too. Let's say we have f of x. Let me give you an example here. So let's say we have f of x equals x squared minus 2x minus 3, or we can write it y equals x squared minus 2x minus 3. So I'm trying to show you we can say f of x equal or y equal. Okay, or similarly we can say h of x equals something something something, or y equal same thing. Okay, so how about graphing functions? Let's say we have two functions y equals 2x. As I say before, we can write it like y equals 2x or f of x equal 2x. And similarly, we can write this one, f of x. We cannot write it. Okay, let's leave it like that. Or maybe we can write it like f of x equals plus or minus square root of x. Okay. So we have two functions like that. When we graph them, we will find these two graphs. So how can I decide these are function or not? So simply I will use one vertical line. Okay. So when I use vertical line, let me use it again. Let's say this red vertical line, my vertical line test. So when I put my vertical red line, it's intersect only one point of the function, right? It's only intersecting, let me point it here, right? Only one point on the function. So when I move this this red line on the function, it's always intersecting one point, not more than one point. Let's say I put it here. So now it's intersecting this point here, right? So what we say here, this is a function because it intersects vertical line only one point. Okay, how about this second example? Let me use same vertical line here. So when I put this vertical line on the graph anywhere, let's say I put it here, as you can see, it's intersecting function in 2 points, 1 point here and 1 point here. So we said this is not a function, because intersects vertical line more than 1 point. Okay, so let's move this vertical line another, let's say I will put it here. We will see again it's intersecting 2 points everywhere. Okay, it's easy. Just put vertical line on the function and see how many points it's intersecting. How about domain and range? So when we say domain, actually we will think all possible possible values that x can get. And there's two rules for domain. The first rule is denominator. If there's a denominator, denominator cannot be equal 0. If we have denominator in our function, it cannot be equal to 0. And second rule is if there's a radicand, it should be equal or bigger than or equal 0. So let me remind you what was a radicand. Radicand is inside of the square root or root. Okay. So how about range? So since we know the domain is possible x values, range is possible y values can get. So it's depending on the x values. When we find what is our domain, we can guess what is our range. So let me show you in an example. In here we have a denominator. So we will say denominator cannot be equal 0. So I will say denominator, which is 2x minus 5, cannot be equal 0. So when I simplify it, let's say I will simplify it plus 5 plus 5. So when I add 5 both sides, I will get 2x not equal 5, which is when I divide it by 2 both sides, I will get x cannot be equals 2.5. Okay. So my domain, I can write it like domain x is, which is x cannot be equals 2.5. Or I can write it domain like that. Negative infinity and 2.5 union 2.5 and positive infinity. So this says we cannot take 2.5, but we can take other values. So let me show it with graph what I'm talking about, so we can understand better with graphs. From here, make graph. So this is my graph, as you can see. So when I move on the function on the graph, for every x values I have one y value, right? But when I have x equals 2.5, which is here somewhere, so you can say there's no y values here. Okay, otherwise we have every point we have y value. Like when I have x equal 3, I have y 20.94. Okay, but when I come to the 2 point, yeah, I cannot go there. Like, yeah, it goes to the infinity on that side. Yeah, and here also goes to the negative infinity. So I cannot get exactly one y value when x equals 2.5. Okay. Let's see another example. So we said for radicand, we must say radicand should be equal than bigger than equal 0. So x minus 3 should be bigger than equals 0. X minus 3, so I will put plus both sides, and then I will get x bigger than equal 3. So I can write my domain now. My domain in here, x bigger than equals 3, or I can write domain includes 3 and goes to the positive infinity. Since I have bigger than an equal sign, I should use this bracket, and then goes to the infinity. So let me show this example in the graph. Where's my graph? Here. So this is my graph, okay? So when I have x equal 3, I have y equal 0. So x equal 3 is included. But less than 3, when x equal, let's say I have x equal 2, I don't have y value. So it starts from x equal 3 and the bigger number, like x equal 4, x equal 5, goes to the positive infinity. Yes, so these x values, I have y value, but when I have x equal 1, 2, or less than them, I don't have any y values. And also we can write range here. Let's say here my range, as you can see on the graph, y is bigger than equal 0. All the y values bigger than equal 0. So let's see another example here. So we have y equal to x plus 3. So it's a function. As you can see on the graph, let's see on the graph. So this is my graph. So as you can see, this graph, every x value has a 1 y value. So if I put vertical line here, it will intersect only 1 points. So this is a function. So let me write it down. So this is a function. So every x value has only 1 y values. So how about domain and range? This domain x is, so as you can see on the graph, let me make it smaller. So when I make it smaller and smaller, actually I see same graph. So it goes from negative infinity to the positive infinity. I'm using all the x's between them. So I will write domain negative infinity and positive infinity. This is my domain. And my range also similarly, actually, it's y's. And as you can see on the graph, I'm using all the y values, like here 5, 6, 7, 8. Like when I go to the down, I'm using like -2, -3, all the y values I'm using. So similarly, my range is between negative infinity to the positive infinity. Okay. Let's say our question is asking us, what is f of 3? How can we answer this question? So since our function is f of x equals 3x plus 2x plus 3, so I can write it like that, right? So when I find f of 3, Actually, I'm just simply putting 3 when I see x. So 2 multiply by 3 because there's x plus 3. So f of 3 equals 6 plus 3. So f of 3 is 9. Which this means when x equals 3, my y is equal 9. Let me check it on the graph. So let me find x equal 3 here. Yeah, it's equal to 9, right? When x equals 3, y equals 9. Okay, so let's say the question is asking if x plus 1. How can I calculate this? So since I know f of x equal to x plus 3, so I will put x plus 1 for x. So I will multiply 2 x plus 1 because when I see x, I am putting x plus 1 and plus 3. And it's equal 2x plus 2 plus 3, which is 2x plus 5. Yes, it's easy. So let me show it with colors. So when I see x, like here, I am putting x plus 1 and make just algebraic operation on it. Yeah, that's it. So that's it for today. Hopefully you like it. If you like my videos, please subscribe my channel and see you in the next video.